Welcome to Study Loop.
So here we have two wires, the green wires, and there is a metal wire of mass 24.1 milligram here, the red one. Let me write down this here. So there is a wire of mass 24.1 milligrams. Now as the current is flown through the circuit, so the question is asking it at certain time 61.1 millisecond, what would be the speed of wire? This wire is now moving as the current is on, and in which direction does it move, the left or to the right? Okay, to the left or right. So this we have to figure out. So for this we have to use the right hand rule here. So as the current moves in here, current follows along this, B is along this. So by using right hand rule, if the charge is positive, the force is along left, and if the charge is negative, force is along this. Now since current is considered to be positive, so I is considered to be positive, so the force should be on the left. So we can just first say, since the force is on the left, this wire should also move towards the left, right? So just we can say the answer for B using right hand rule. Right hand rule, force is along left, right? Now what is the magnitude of the force? Let's just first find that out so that we can figure out the acceleration and then finally the velocity. So the force that it experiences is equal to B I L sine theta. This is the formula, right? Where theta is the angle between B and L. So we have the value of B here, that is equal to 56.3 Tesla, millitesla, which is equal to 56.3 milli. So 10 to the power minus 3. What is the current here? Current is given as 9.13 milliamperes. So into 9.13 into 10 to the power minus 3, right? And what is the length? It is given as d, that is equal to 2.56 centimeters. So let me write that in meters, 0.0256 meters. And what is sine theta? That is 1, because the angle between this wire and the magnetic field is 90 degrees. So if you calculate this comes out to be force is equal to force on the wire equals to 1.316 into 10 to the power minus 5 Newton, right? So with this force, how much acceleration will the wire gain? So acceleration is equal to force upon mass. So this is equal to 1.316 into 10 to the power minus 5 upon mass is given in milligrams, right? So 24.1 into 10 to the power minus 3, right? No, gram is not SI, it's kg, kilogram is SI. So you want to convert milligram to kilogram, so 10 to the power minus 6. This is the place where a lot of students get mistakes, so be careful with this, converting milligram to kilogram. So it is our habit to write 10 to the power minus 3 as we see milli, right? So but we have to convert this 10 to the power minus 3, will convert this into gram, which is not SI, but SI is kg. So to convert into kg, multiply by 10 to the power minus 6. In this case, now acceleration will be 0.546 meter per second square. Alright, now what else do we need? So we need the velocity at which it is moving. So velocity v is equal to, using the equation of motion, v is equal to velocity, initial velocity u is 0, acceleration and time are given. So acceleration that we just found out, so 0.546 is acceleration, and the time it says is how much? 61.1 milliseconds. So 61.1 into 10 to the power minus 3 seconds, right? So just multiply this here. This will give me 3.34 into 10 to the power minus 2 meter per second. So this gives me the velocity at which the wire will move towards the left. So this is the solution for this question. Thank you for